What is up, team? Today we're talking trigonometric ratios. Got a learning target right here. It says I can calculate and understand the sine, cosine, and tangent ratios in a right triangle. So here we go. Let's get after it. I got three triangles here on the board. These three triangles, they're similar triangles. We can see that because they have corresponding angles that are congruent, all three of them. So all three of them are similar to one another. We could figure out scale factors and all that sorts of stuff, but I'm telling you that they are similar and we're going to work with them in that way. So what I want to do is I made a table over here and I just want to examine some relationships. The relationships I want to examine have to do with opposite and adjacent legs. So we spent some time looking at opposite and adjacent legs, and I was like, I understand it, but that's kind of weird. So today we're going to put it to practice. So we're going to focus over here on this larger triangle, and you'll see the top row of my table. We're focusing specifically on angle A. So all of these things we're about to look at, we're looking at it from the perspective of angle A. So the first ratio that I want to examine is the opposite leg over the hypotenuse. So we're just going to make a fraction. The numerator of the fraction is going to be the length of the opposite leg. The denominator is the length of the hypotenuse. So angle A is here. The opposite leg is straight across. It has a length of 9, and the hypotenuse right here is 15. So we're just going to do 9 over 15. And of course, this can reduce a little bit. Let's think of the greatest common factor of 9 and 15. I think it's 3. So this is going to end up being 3 over 5. Cool, not so bad. Let's move forward. So now we're going to look for the adjacent leg over the hypotenuse. Again, still examining angle A. Angle A, the adjacent leg is 12. The hypotenuse over here is 15. So it's just going to be 12 over 15. And again, we can reduce this business. I think we have a greatest common factor of 3, so it's going to be 4 over 5. Great. The last one, opposite leg over adjacent leg. Again, from the perspective of A. The opposite leg is 9. The adjacent leg is 12, and we can reduce that one as well. 9 over 12, which is going to end up being 3/4. Okay, cool. I'm going to do the same thing with angles D and angle G, but I'm not going to throw that in the video. All right, I filled out the table. Go ahead and pause if you need to. I'm not going to discuss them all. What I need you to notice, though, is if you look at each of these columns, the opposite leg over hypotenuse, this ratio, it's the same thing all the way down. In this case, it's 3/5. Adjacent leg over hypotenuse, it's 4/5, the same thing all the way down, and the other one is 3/4 all the way down. Not a coincidence. That's very much on purpose. So think about it. We have three similar right triangles. So the corresponding sides are proportional with all of these. So it makes sense. If we took ratios of corresponding sides that are already proportional, we're going to get the same thing. These three ratios in particular, super, super important. We're going to spend a ton of time with these. They even have names, and we're going to discuss them really for the rest of this video and for the next while. So get used to these names here. This first one, the opposite leg over the hypotenuse. The name of this ratio is sine, S-I-N-E. So I'm going to write that up here, S-I-N-E. This is the sine ratio. The second one, adjacent leg over the hypotenuse. Didn't give myself a lot of room to work, so I'm going to write it underneath. This one is called the cosine ratio, adjacent leg over hypotenuse. The third one here is the tangent ratio. Tangent ratio. We're going to be using these three a lot. You're going to have to memorize these ratios. You'll have your notes available, but it's just going to be so much quicker if you memorize these. So there are a few tricks. So what I'm going to do here is I'm going to show you kind of a mnemonic device of sorts. That maybe it'll work for you, maybe it won't. So one way that a lot of people like to think of these ratios is using this phrase called SOHCAHTOA. Those aren't real words, but it's easy to remember. It kind of rolls off the tongue a little bit. And here's what it means. So is S-O-H, ka is C-A-H, and toa is T-O-A. Again, I know they're not real words, and this looks real weird, but SOHCAHTOA, here's what this means. Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse, that's the AH, and toa, opposite over adjacent. Some folks might stylize it slightly different. I've seen it like this. This might help you. Ka, and then toa, really showing the ratios there, the fractions there. So SOHCAHTOA, big deal important. Talk to anybody who's ever done a geometry class, ever. they'll talk about SOHCAHTOA. We're going to practice using SOHCAHTOA here in just a moment. Okay, here we go. Real quick example. We are going to zoom in just on the larger of these three triangles. We're going to focus on angle B this time, because we already did A over here. So if we want to find the sine of angle B, we need to do opposite over hypotenuse. SOHCAHTOA, S-O-H. So we're going to start from the perspective of angle B, go to the opposite, which is 12, and the hypotenuse is 15. So it's 12 over 15. The sine of angle B is 12 over 15. If we reduce this, again, it looks like 3 goes into both these, so it's going to be 4/5. Great. Cosine of B. Adjacent over hypotenuse this time. This is the cos, C-I-H. Cosine is adjacent over hypotenuse, which is 9 over 15. And that reduces to 3/5. Lastly, tangent of angle B. That is opposite over adjacent. So we're going to go 12 over 9. Improper fraction, but it's going to work just fine. Ends up being 4/3. Now, just for funsies, let's look at these in decimal form. There's going to be a reason for this here shortly. 4/5, that's the same thing as 0.8. 3/5, that's 0.6. And 4/3, that's like 1.3 repeated. Now, last thing I want to show you is we can calculate the sine of angle B using a calculator. If you have the angle measure, we're going to learn how to press these buttons or what these buttons mean on our calculator. So I have the TI-30X. This is definitely what I'd recommend you getting. I remember early in the year sharing, hey, you're going to need this calculator later on in the year. This is where it kicks in. So if you don't have one of these, please make it happen. Here's what mine looks like. If you have something that looks like this, that'd be a huge win. So there's these buttons here, sine, cosine, and tangent. They look like sin, cos, and tan. We're going to practice all three of them today. Angle B here is a 53-degree angle. And that's not exact. I did round. It's pretty much 53 degrees. I just didn't want to put the decimal in there for the sake of the beautiful figure here. So you'll see when we get this, we're going to end up with a decimal that we have to round, but work with me. Trust me that this works. Okay, so if we're looking for the sine of B, let's switch colors here. The sine of, no, we don't even need colors. Sine of B. B is 53 degrees. So I'm just going to type the sine button in my calculator. It's going to open up a parenthesis, and I'm going to type in 53. So sine, right here, 53, close my parenthesis. Let's get the glare, there we go, equals, and then we see 0.798. If we round that to the nearest hundredth, we get 0.8, which is, of course, is exactly what we expected, 0.8. It's the same thing as if we did it by hand. Next one, cosine of B. So same sort of thing. I'm pressing cosine of 53, close my parenthesis, equals, and I get 0.60. So if I round to the nearest hundredth again, 0.6, that matches what we have. And tangent of 53 in the same way. Tan of 53, that glare is killing me. There we go. And we get 1.32. So 1.3 is what we had previously. So this is trigonometric ratios, the ones that we're going to use mostly in a nutshell: sine, cosine, and tangent, SOHCAHTOA, and how to find these things on a calculator. All right, practice problems are in classroom. Let me know if you have questions. You got this.